Hi everyone, welcome back once again. We are still continuing with your grade 12 November 2021 past paper questions, and today we're going to be doing question 2 in sequences and series, and we're going to be focusing on this that focuses on geometric sequence. Right, question 2, given the geometric series x plus 90 plus 81 plus towards infinity 2.1, they want you to calculate the value of x, right? So we are told that this is a geometric series, right? So in a geometric series, there's something that is common, and that is what? The ratio, right? The ratio is common, meaning that if you take term 2 and you divide by term 1, it will be the same as the next term, term 3, divided by the previous term, which is term 2. So the ratio is the same, right? So we can use this ideology to solve for x. We know that this is term 1, this is term 2, and this is what? Term 3. Okay, so what is our term 2? It's 90. What is our term 1? It is x is equals to, what is our term 3? Is 81. What is our term 2? It's 90. Okay, so how are we going to solve for x? We can simply what? Cross multiply, right? So it will be 81 multiplied by x, which will be 81x. 90 multiplied by 90 on your calculator, you'll get 8,100. Okay, so for x, we can simply divide both sides by what? By 81. So 81 and 81 cancel, and we're gonna get x to be equals to 8,100 divided by what? Divide by 81, which will give us what? 100. All right. 2.2, show that the sum of the first n terms is equals to Sn, which is equals to 1000 into 1 minus 0.9 exponent n. Okay, so they want us to show that the sum of the first n terms will be equals to that value there. All right, expressed obviously in terms of n. So we know that this is a sum of what? Of a geometric series, right? So then we can use the formula for sum of a geometric series that says Sn is equals to what? A into r exponent n minus 1 over r minus 1, or we can use this formula Sn is equals to A into 1 minus Rn, right, over what? Over 1 minus r. Which one between the two do you think we can use? So we can just simply look at this expression inside the brackets. It says 1 minus 0.9 exponent n. Probably they'd use 1 minus r exponent n, right? Meaning that we're going to choose that formula because it will be easier for it to use it to be able to express that sum in terms of that thing, right? So a, we know that a is the same as term number 1, which is what? Which is 100. What is our r? R is equals to the next term divided by the previous term. We can see term 2 divided by term 1. So 90 divided by 100. So our r will be equals to 90 divided by 100, which is 9 over 10. All right, 9 over 10. Also, when you say 81 divided by 90, we must still get the same 9 over 10. All right, to confirm that your common ratio is actually common, or rather the same. Okay, so we can now go and get the sum of the first n terms. We don't know the number of terms, they just say sum of the first n terms. So we remain, n will remain n. What is our a? Our a is 100. 1 minus, what is our r? Our r is 9 over what? 9 over 10, which is the same as what? As 0.9, right? Exponent what? Exponent n, all divided by 1 minus r, which is 0.9. Okay, so we can just put this in brackets. Then we can go and simplify. So it's gonna be 100 into 1 minus 0.9 exponent n, all divided by 1 minus 0.9 is gonna be 0.1, right? 0.1. So to finally simplify, we can just simply say 100 divided by 0.1, open brackets, 1 minus what? 0.9 exponent what? Exponent n. So what is 100 divided by 0.1? So when you simplify that, it will definitely give you what? 1000 into 1 minus 0.9 exponent n. So we have finally expressed this as they wanted it. All right. Conclude with 2.3. It says hence or otherwise calculate the sum to infinity. What does the word hence mean? Again, we said it means that the solution in your previous question should enable you to calculate this question. All right, so in the previous question, we were able to deduce that A is actually equals to 100, right? And also to deduce that R is equals to 9 over 10, which was the same as 0, what? 0,9. So with these two information, we can now go and get the sum to what? To infinity. The formula says A over 1 minus R. What is our A? A is 100 over 1 minus what is our R? Is 0,9. So always notice that after a negative, whatever answer that is there, we put it in brackets to avoid making mistakes with the signs, right? So to be 100 over 1 minus 0,9, so which is the same as what? As 1000. All right, as 1000. And you can recall this from the previous question, because from the previous one we had Sn is equals to 1000 into 1 minus 0,9 exponent n, and this 1000 actually was gotten by saying 100 divided by 0,9. all right, I mean by 0,1, which was the same as what? As 1 minus 0,9. That's why they said hence, right? They didn't actually want you to use a calculator, but to recall quickly that 100 over 1 minus 0,9 was actually in the previous question, and we calculated it to be what? To be 1000. So you can quickly give them the answer there. All right, great stuff. That's all for me. Thank you very much for joining us today. Otherwise, watch out for the next sessions. Thank you very much for joining, and goodbye.